Bonjour and good morning. Welcome to WASA Distance Education and PLAR Math. And this is our first week back after the Christmas break. So we're in week 7 now, and we have 2 more weeks of classes after this week left in term 1B. So if you want to finish up in term 1B, try to get your work finished and send it out as soon as possible. And of course, be ready for starting in term 2A. In term 2A, we will be offering the PLAR English and the PLAR History Geography by radio Zoom. So in the classes. So if you want to do that, make sure that you are ready for it. To participate in classes, you can use radio or Zoom. The instructions for joining the classes are in the study guide. You can ask your DEC or you can contact me as well. All PLAR Math students are welcome to attend the classes, so it doesn't matter what you signed up for, IL or Radio Zoom, you can still attend the classes. And if you can't attend the classes because of work or some other responsibilities, then you can always watch the recorded classes that are uploaded to YouTube. To contact me, you can use email, phone, or send a message on Facebook. All of my contact information is on the cover page of your lessons and the study guide. So the classes are recorded and uploaded to YouTube. So the classes from last term, the PLAR English and the PLAR History Geography from term 1A are still available on YouTube. You can find them on my YouTube channel for the PLAR Math and the PLAR English, or you can use the WASA Distance Education Center YouTube channel for all of the subjects that we teach via Radio Zoom. So that all of the courses are there. So the PLAR Science, you will find the PLAR Math, the PLAR English, and the PLAR History and Geography as well. Okay, on the WASA Distance Education YouTube channel, my channel, you'll just find the PLAR English and Math. After this term is over, I won't be posting my classes to my YouTube channel anymore. I won't be updating them. They will be posted on the WASA Distance Education Center YouTube channel, so you can find them there. Just a reminder to students, for PLAR students, if you do not finish your work in this term, you can continue it into next term. PLAR students are not withdrawn at the end of the term. Once you sign up for PLAR, at any time of the year, you're in until the school year is over, and you only then have to reapply the following year. Once you apply in the school year, you're in for the whole year, and you just have to contact us if you want a different subject, a different PLAR subject. And just a reminder that all PLAR students have the option of writing the culminating activity instead of doing the lessons and the key questions. So even if you have completed and submitted some of the key questions, you can still choose the option of writing the culminating activity. So if you've done a few questions, you've looked at the lessons, and you go, I know how to do all this stuff, then you can request the culminating activity, and then you don't have to do or finish up the key questions. You'll get your missing credits if you pass the culminating activity. And if you don't pass the culminating activity, then you will have to go through the lessons and complete the key questions, and then you can write another culminating activity after you've done that. If you are doing the lessons, you'll notice that there are 2 types of questions in the lessons, the support questions and the key questions. The support questions are the practice questions that you do on your own. The answers for the support questions are near the end of the lesson, right before the key questions. So do the support questions as you go through the lesson, then jump to the back, check your answers against the answers given there. If you're doing well with the support questions, so getting most or all of the questions right, then you do the key questions. If you're having problems with the support questions, then you need to go back, reread the lesson, contact me for help, or watch the classes again, and then try the support questions again. If you submit your key questions and you're making a lot of mistakes, I will send them back to you and say, please make corrections and resubmit. Okay, so you will have to make changes because if you're doing the lessons, then you need to pass all of the lessons to rate the culminating activity. If you're struggling with the lessons, then you will probably not be successful with the culminating activity, so keep that in mind. For submitting your work, there are several ways. First of all, you can give it to your DEC, and then your DEC will send it out to us here in Sioux Lookout. If you don't have a DEC or a learning center, or your DEC is away, then you can submit your own work, and there are several ways of doing that. Sorry. If you have access to a scanner, you can scan and email your own work. Send it to studentwork@nnec.on.ca and make sure you CC it to me. Or if you have access to a fax machine, you can fax your work to us. Okay, if you don't have access to a fax machine or a scanner, then you can still submit your work using your smartphone. If you are submitting your own work, make sure that you write your name, the subject, and your teacher's name on your work. So if you're sending it directly, from your computer or from your Facebook to us, make sure your name is on it. It's not so bad for sending it by Facebook because we know who's sending it, unless of course you're not using your real name, and then we might have a bit of trouble trying to figure out who it's from. So make sure you print your name somewhere on your work on the front page so that we know who it is from. For using your smartphone, you can either take photos of your work, or you can scan your work using the built-in scanner, and then you either email it to studentwork@nnec.on.ca, that same email address, and CC it to me. Or if you can't send it by email, then you can send it using Facebook Messenger. Okay, you can either send the pictures or you can send the scanned document. You can also, if you're in Sioux Lookout or in the surrounding area and you come to Sioux Lookout fairly often, you can use our outdoor mailbox, which is located at the side of the building in the WASA parking lot. Okay, so the side of the building that faces the post office. Or you can knock on the front door, not the side door, and give it to whoever answers the door. You can also use Google Docs to complete your work, and then you can send me the link. I've had several students do it this way. Send me the link and then I'll get your work that way. Or the last option is to use Google Classroom to complete and submit your work. So lots of ways to get your work to us, even if you do not have a learning center in your community. Another thing I want to mention is that, as I mentioned at the beginning, the end of the term is coming up fairly quickly, only 2 more weeks. Just a reminder that at the end of term 1B, we will be having 2 student draws. One for students who earned a credit, so you finished your course in term 1B, and one for students who submit your work. So if you submit a lesson, so I should say for every lesson you submit, your name will be entered into a draw. So for the PLAR, there are 5 lessons. If you submit all 5 lessons in the term, then you get your name entered 5 times into the draw. If you submit all of your work, so 5 lessons, and you earn your credit, then you get entered into the second draw. So you have the opportunity to win 2 prizes at the end of the term. We're not quite sure what the prize is going to be yet, but that will be announced once we know. Okay, so only 2 weeks left in term 1B, so get your work finished and submitted. All right, so that's it for the announcement. So we're going to start off with a review of what we did in class on Tuesday. So we started lesson 2 on Tuesday. Lesson 4 on Tuesday. So we were working on lesson 4 on Tuesday, and so we talked about in lesson 4, we're getting more into algebra, as I said on Tuesday. So we talked about adding and subtracting polynomials. So polynomials are terms that they're expressions that we add or subtract. We can complete with operations. So adding polynomials or subtracting polynomials is just a matter of combining like terms. There are a couple of formats for adding and subtracting polynomials. So you can do it horizontally. So I should mention combining like terms means that you have to look for terms that have the same letter and the same exponent. So if they don't have the same letter and the same exponent, so the same letter or the same variable, then they are not like terms and you cannot add or subtract them. So you have to look very carefully excuse me, at the expression to make sure that you can do something with it. So again, there are two ways of doing it. You can do it horizontally, so basically from left to right. So 2x plus 5y plus 3x minus 2y. So the first thing you're going to do here to solve for this expression is get rid of the brackets. So clear the brackets first. So you're just going to rewrite it without the brackets. 2x plus 5y plus 3x minus 2y. Okay. Now we're going to group the like terms. So it says in accordance to their variables, which means group them by their variables. So 2x, and then I've got plus 3x, so I have to take that plus sign that's in front of the 3x with it so that I know I'm adding. And then my y terms, I've got plus 5y and minus 2y. So I need to move that, move the signs, the operation with the term so that I know if I'm adding or subtracting it. So remember to do that. Otherwise, you're going to end up making mistakes. They're not all addition. Okay, so now I can combine my like terms. So I've got 2x plus 3x. So in order to combine, I add the coefficients. 2 plus 3 is 5x plus, and so I've got 5y minus 2y. So here I'm subtracting. So 5 take away 2 will give me 3y. So now I've got an x term and a y term. I can't add those because they're different terms. They're now what we call unlike terms. So now I just leave that as it is. 5x plus 3y is my answer. Okay, so you can also add vertically if that works better for you. So in order to do it vertically, you're going to stack the like terms. You're getting rid of the brackets again. And then I'm going to put my like terms underneath. Okay, so 2x plus 5y and 3x minus 2y. So I'm going to add my x terms. 2 plus 3 is 5x. Subtract my y terms. 5 take away 2 is positive 3, so plus 3y. And so I end up with the same answer that I ended up with before. So it doesn't matter which way you do it, whichever way makes more sense to you, whichever way you feel more comfortable with, that's the way you do it. Okay, so that's adding and subtracting polynomials. Remember, they must be like terms to add or subtract. We also looked at multiplying monomials. So a monomial is a one term. When a monomial is multiplied by another monomial, their product will be a monomial only. So with the polynomials, our answer was two terms. Our answer ended up being a binomial, so 5x plus 3y. With monomials, we're still going to end up with a one-term answer, no adding or subtracting in the answer. So a monomial, so we said mono means one, so a monomial has only one term in it. The coefficients of the monomials are multiplied together, and then the variables are multiplied. So with the polynomials adding and subtracting, we added the coefficients and kept the variable the same. With multiplying, we're multiplying the coefficients, so 2 times 2 equals 4, and then we've got x times y equals xy. Okay, so in the next one where we have exponents, and we have to remember that it's understood that these are exponent 1. So if it's just a letter by itself, it has an exponent of 1. So here we're going to multiply our numbers. 3 times 6 is 18. And then we're going to multiply our variables. So we've got x to the power of 9 times x to the power of 4. So because we're multiplying, we're going to use exponent rules here. We're using the product rule. So x to the power of 9 times x to the power of 4 is x to the power of 9 plus 4, which is 13. So our answer is 18x to the power of 13 and y to the power of 9, because we don't have another y variable to multiply by, so that's just going to stay the same. So our answer is 18x to the 13th power, y to the 9th power. Okay, so be very careful when you're multiplying monomials. Watch out, remember to use the exponent rules. Okay, so we're going to be finishing up, this is lesson 3. We're going to be finishing up lesson 3 today. So we've done exponent rules, order of operations, like terms, adding and subtracting polynomials, and multiplying monomials. So now we're going to look at expanding expressions, and we'll be starting lesson 4 today as well. I was thinking we started it already. Okay, so in your lesson, bottom of page 20 talks about expanding expressions, which is the distributive property in math. So it explains it there on the bottom of page 20, then a little bit on an example on the top of page 21, and your support question number 6 on page 21. Okay, so expanding expressions. Sometimes you might hear it called expanding brackets. To expand an expression or a bracket means that you multiply each term inside the brackets by the expression that's outside the bracket. So for example, in the expression 3 and then in brackets m plus 7, we're multiplying the m and the 7, what's inside the bracket, by the 3 that's outside. So do it one step at a time. So 3, so this, remember, if there's just a number and a bracket, so it's just like saying 3 times m, we have 3 times m, and we also do 3 times 7. So the 3 has to multiply by both. 3 times m is 3m, 3 times 7 is 21. So your answer is 3m plus 21. Okay, so expanding brackets involves using the skills of simplifying. Remember that 2 times a equals 2a and a times a equals a squared. Not quite sure why that dot is where it is. Okay, so now next one, expand 4 times 3n plus y. Okay, so we multiply our 4 by the first term that's inside the brackets, 3n. So 4 times 3n, and then we multiply by y as well, so 4 times y. So there's a plus there, there's a plus there. So 4 times 3n, multiply the numbers. 4 times 3 is 12n. 4 times y is 4y, so the answer is 12n plus 4y. And here we have unlike terms. So remember, thinking back to adding and subtracting polynomials, these are unlike, so we can't do anything with them. We can't add them because they're different terms, they're unlike terms. Okay, expanding brackets with powers, so having exponents. So using power laws, so think about the exponent rules, terms that contain powers can be simplified. Remember to use power laws when multiplying expressions that contain powers. So if you're multiplying a squared times a cubed, a squared means a times a cubed means a times a times a. So how many a's do you have? 1, 2, 3, 4, 5. So a to the 5th power. Okay, so an example here. If you have exponents, expand the following. So we've got 3b squared times 2b cubed plus 3b. So you're going to do 3b squared times 2b cubed plus 3b squared times 3b. Okay, so 3b squared times 2b squared, multiply your numbers, 3 times 2 is 6, and b squared times b cubed is b, 2 plus 3 is 5, plus 3b squared times 3b, multiply your numbers, 3 times 3 is 9, b squared times b, and that's b to the first power, is b to the third power. Okay, now we've got our final answer, and this, even though they both have the base of b, they have different exponents, so we can't add the coefficients. So our answer is 6b to the fifth power plus 9b to the third power. Okay, the exponents are different, so they are unlike terms. So this is our answer. Okay. Another example down here. Negative times x minus 3. So when there's just a negative sign in front of the brackets, it is understood to mean that we are multiplying every term inside the bracket by negative 1. So this is actually the negative, and then x minus 3 is a negative 1. So we're multiplying negative 1 times x, which is negative 1x, and negative 1 times negative 3, which is positive 3. Remember your rules, a negative times a negative equals a positive. So we end up with negative 1x, or just negative x, you don't have to put the 1 in there, plus 3, because negative 1 times a negative 3 is a positive 3. So our answer is negative x plus 3, and that's our answer. Okay. Expanding and simplifying. Expressions with brackets can often be mixed in with other terms. For example, 3 and then h plus 2 in brackets minus 4. In these cases, first expand the bracket and then collect any like terms. So for this example, the 3 times h plus 2 minus 4, we're going to do the bracket part first. So 3 times h plus 3 times 2, and then we're going to bring down the minus 4. We're going to carry that with us. So 3 times h is 3h, 3 times 2 is 6, and then keep that minus 4 there. So now 3h we can't do anything with because there's no like terms, but we can subtract 6 and 4. So 6 minus 4 is 2, so there's our answer, 3h plus 2. Example 2, expand and simplify. This one looks tricky. 6g plus 2g times 3g plus 7. So here we have to follow BEDMAS, but we always have to do the bracket part first. So multiplying out the brackets must happen before completing the addition. So multiply out the bracket first. So 6g, we're just going to bring that down, and then we're going to do 2g times 3g and 2g times 7. So this is our expanded expression here. So now bring the 6g down, multiply 2g times 3g, which will give me 2 times 3 is 6, g times g, g squared. 2g times 7, 2 times 7 is 14 with just g. Okay, so now we have 6g plus 6g squared plus 14g. So collect the like terms. So 6g and 14g are like terms. So we add those together. 6g plus 14 will give me 20g, and the 6g squared, because it has the larger exponent, goes first. You can write it as 20g plus 6g squared, but the answers are usually written, as I mentioned before, with descending order of power. So the biggest power first. Okay, so you have to remember your exponent rules when you're doing these. Okay, so let's do a little bit of practice with expanding expressions. So 6 times negative 4 minus 7q. So let's expand it out first. 6 times, I'm going to use brackets here so I don't get confused, plus 6 times 7q. Okay, so 6 times 4 will give me, or negative 4 will give me negative 24 plus 6 times 7q. 6 times 7 is 42q. Okay, so negative 24 plus 42q. And I can't add negative 24 and positive and 42 because 42 is an unlike term. It's not like negative 24. One's a constant, one is as a variable. Okay, number 2, 9 times 8 plus 7p. So let's expand first. 9 times 8 plus 9 times 7p. 9 times 8 is 72 plus 9 times 7, 63p. Okay, unlike terms. So these are, the answers will be binomials generally, or polynomials. So next one, number 3, negative 8 times 6d plus negative 8 times 5. So negative 8 times 6 is negative 48d plus negative 8 times 5 is negative 40. Or you can write it as negative 48d minus 40. Okay, plus a negative 40, same thing as saying minus 40. So you have less operations, less signs in there. Okay, let's go to the next page where we have some that are a little bit more complicated. So number 11, we've got negative 7h minus 9 times 2h minus 6. So remember, we have to do the brackets first. So negative 7h is going to stay there. And then I'm going to multiply negative 9 times 2h. I can do 9 times 2h, but then I'd end up having to change some signs after. So I'm going to do negative 9 times 2h, which is negative 9 times 2 is 18h. And then I have negative 9 times a negative 6, which is positive 54. So now I have negative 7h minus 18h plus 54. So now I can combine my like terms. Negative 7h minus 18h. So remembering your rules, negative 7h plus negative 18h will give me negative 25h plus 54. Okay, so there's my answer. Okay, number 12, negative 4 times negative 9z plus 7 minus 2. So I'm going to expand my brackets first. Negative 4 times negative 9z plus negative 4 times 7 minus 2. Okay, so negative 4 times negative 9 is positive 36z plus negative 4 times 7 is negative 28 minus 2. Okay, so 36z is the only term with a variable, so I know that's not going to change, but I can combine negative 28 minus 2, which will give me negative 30. Negative 28 plus negative 2. So negative 28 plus negative 2 will give me negative 30. So my answer, 36z plus 30. So you can see how I'm ending up with a binomial as my answer. There are two terms in my answer. One has a variable, one does not. Let's see, is there a different one down here we can do? Let's do number 17. So we've got a negative 7 minus 9 times negative 4 plus 2q. So that negative 7 I'm going to leave. I'm not going to do negative 7 minus 9 because remember we have to do the bedmass rule, which means we have to do brackets first. So negative 7 is going to stay there, and then I'm going to do negative 9 times negative 4, which will give me a positive 36, and then negative 9 times positive 2, which will give me a negative 18q. Okay, so I'm just going to write this out so you can see what I'm doing. Negative 7 minus 9 times negative 4 plus negative 9 times 2q. Okay, let's put this in brackets and this in brackets. So I'm doing the same thing. So negative 7 negative 9 times negative 4, or I can do negative 7 minus 9 times 4. Negative 4 is negative 36, plus negative 9 times 2 is negative 18q. So I've got here I got negative 7 plus 36 minus 18q. Here I've got negative 7 minus a negative 36. Remember, when you have minus a negative, it's plus. And then I can do plus negative 18q, or I can just say minus 18q. So anyway, in any case, now I have to combine my like terms. Negative 7 and positive 36 are both constants, so they don't have letters, so they are like terms. So negative 7 plus 36 will give me 29, and then minus 18q is my answer. Over here, same thing, combine my like terms. I'm still going to get 29, and I can write it as plus, negative 18q. So these two answers are exactly the same, except I've just written them differently. So 29 minus 18q, or 29 plus negative 18q. Okay, so again, do it step by step. If you're pretty good at this and you can do it in your head, just do your multiplication in your head and write down your answers. If not, write everything out. Okay, and it might be a good idea to write everything out the first few times so that you don't miss anything. I've seen students who will multiply the negative 9 times the negative 4, but then they forget to multiply the 9 times the 2. So remember, whatever's inside the brackets, you have to multiply the number that's outside with it. But only if it's the number that's right before the brackets. If it has, if it's like this one, where you've got negative 9b plus 3, then only the 3 gets multiplied by everything in the brackets, not the negative 9b. Okay, because you're adding the negative 9b. So actually, let's do this one. So negative 9b plus, and then 3 times 8 plus 3 times 4b. So negative 9b plus 3 times 8 is 24, plus 3 times 4 is 12b. So now this one, this time our like terms are the terms with the variable. In most cases they've been the constants, but this time they're the variable terms. So negative 9b, I'm going to put them together, plus 12b plus 24. So negative 9b plus 12b, my like terms, I end up with 3b plus 24. Okay, so that's how you expand expressions. So key question 18, last key question in lesson 3, expand the following expressions, then simplify. Be careful. Take your time. This one here, b, there's a negative sign outside. That means a negative 1 times 4x minus 15t plus 5w. Okay, that's a negative 1. Don't forget that. The last one down here, G, it looks tricky, but do the first brackets first, then do the second brackets, then look for like terms. You're going to have a lot because there's an x, y, z in that bracket, and there's an x, y, z in that bracket. So take your time doing those, and you're just taking your time and expanding them. So negative 2 times 3x plus negative 2 times 6y minus negative 2 times 2z. Okay, that's just your first bracket. Then you have to do your second bracket, plus 6 times x minus 6 times 2y plus 6 times 3z. So when you expand this one out, you can see that it gets quite long. Okay, so then you just do your multiplication, then you move it around and find your like terms, and boom, you're done. All right, so moving on to lesson 4, solving equations, solving multi-step equations, ordered pairs, graphing linear relations, and slope. So today we're going to have a look at solving equations. solving basic equations. So that starts on page 3 of your lesson. Read through this. So we've got solving equations, we've got information on the notation that is used, and then some examples with solutions. Read through those examples carefully. How to check for them. Several examples, and then support question number 1 for this lesson. Again, do the support questions, check your answers at the end of the lesson. Solving an equation using more than one operation, so having to do add and subtract both, or multiply and divide, or add, divide, multiply and subtract, whatever, in an equation. So take your time doing that. We won't do that. We won't get to that today. So solving equations, what does that mean? So an expression that we talked about before doesn't have an equal sign. An equation has an equal sign in it. Okay, so far we've been looking at expressions. Now we're going to start looking at equations. So the solution of an equation. A solution of an equation is a value of a variable that makes a true statement when substituted into the equation. So when you add or subtract the same quantity from both sides of an equation, you still have equality. So remember when we were working with fractions and we were finding equivalent fractions, we had to add, or not add, but multiply or divide by the exact same number. So it's the same idea here. Whatever you add to one side of the equal sign, you have to add to the other side. So we pretend that the fulcrum here is the equal sign. So if we put one weight on the left, we have to put one weight on the right, which means that the equation is balanced. If we put 2 weights on the right, left, and 2 on the right, then we still have balance. But if we put 1 on the left and 2 on the right, then they are not balanced. They are unbalanced. They're unequal. So you have to do this. Basically, remember to do the same thing on both sides. Okay, so solve the equation x plus 3 equals 8. So it's an equation again because there's an equal sign. So basically what we want to do here is we want to figure out what that x represents. What number is x? Now you can look at this and go, blank plus 3 is 8. Well, I know that's 5. You can figure that one out in your head because 5 plus 3 is 8. So if 5 plus 3 is 8, we would end up with 8 equals 8. So, you can't do all of the problems in your head. So we have to have a way of doing it. So what we want to do is to isolate the variable. So in this case, the x. We want it to be on one side of the equation by itself. In order to do that, we have to get rid of whatever is with it. So in this case, the plus 3. In order to get rid of that plus 3, we do the opposite operation. So remember, we talked about this when we were talking about integers. If you do the opposite operation, it cancels everything out. So the opposite of plus 3 is minus 3. So if we put minus 3 on the left side of the equal sign, we also have to minus 3 or subtract 3 on the right. So keep the balance. So then x plus 3 minus 3, so that 3 is gone, equals x minus 8. So x equals 8 minus 3 is 5. So there's our solution. And we check our solution by substituting the value into the equation to make sure we have a true statement. So x plus 3, we said x is 5, so 5 plus 3, that shouldn't be negative 3. Oh, sorry, no. This is a different one. Sorry, I thought I was doing the same one. So let's show you how our check is. So x plus 3 equals 8. We said our answer for x is 5. 5 plus 3 equals 8. And yes, 5 plus 3 is 8. So 8 equals 8. So that's what we do to check it. We substitute in what we got as an answer. Okay, so solve x plus 3 equals negative 3. So now this one might be a little bit trickier. You might not be able to figure it out in your head because it's a negative number. So what we want to do is get the x by itself. So in order to do that, we need to get rid of that plus 3. The opposite of plus 3 is minus 3. So if we subtract 3 on the left, we have to subtract 3 on the right. So now 3 take away 3 is 0, so we end up with x equals, and negative 3 minus 3, or plus negative 3, is negative 6. So to check it, x plus 3 equals negative 3. So we said x is negative 6, so negative 6 plus 3 equals negative 3. Negative 6 plus 3 is negative 3, so negative 3 equals negative 3. And we've solved it. Okay, when you divide or multiply both sides of an equation by the same quantity, you still have equality. So that was adding and subtracting. Remember, the goal is to undo the operation on the variable. In the example below, the variable is multiplied by 4. So 4x means 4 times x. So in order to get rid of that 4, we do the opposite of multiplication, which is division. So in order to get rid of the 4, we have to divide. So now you can do it two ways. You can do 4x divided by 4 equals negative 28 divided by 4. 4x divided by 4 will leave you with x, because 4 divided by 4 is 1. And then negative 28 divided by 4 is negative 7. Or you can write it this way, which is the preferred way. Sorry. Divided by 4, writing it as a fraction. So 4 cancels out, we're left with x. Negative 28 divided by 4 is negative 7. So you get the same answer. And we can check it. 4 times, we said negative 7 equals negative 28, and 4 times negative 7 is negative 28, and negative 28, of course, equals negative 28. So check your answers when you're done, just to make sure. How do you think we undo division? So what's the opposite of division? Multiplication. So in this one, we've got a over 7 equals negative 42. So we want to get rid of that 7 because we don't want the a by itself. So then we do a divided by 7 times 7 equals, do the same thing on the right, 42. Oh, sorry. Too big. Negative 42 times 7. So we're multiplying both by 7 this time. Okay, so that means that 7 divided by 7 is 1, so we're left with a equals, and 42 times 7 is negative 42 is negative 294. So a equals negative 294. So then we can check. So negative 294, because that's what we said a was, divided by 7 equals negative 42. So negative 294 divided by 7 equals negative 42, and negative 42, of course, equals negative 42. Okay, so solve each equation. So remember opposites. Opposite of addition is subtraction. Opposite of multiplication is division. So here we've got addition, so we need to do the opposite, which is subtraction. Now here we've got the letter on the right-hand side. Generally it's on the left-hand side, but it doesn't matter which side it's on. Okay, if you want to rewrite this as z plus 6 equals 10, you can do it that way. Okay, if that makes more sense to you. But we can also do it this way. So z, and I know I'm going to subtract 6 because I want to get rid of that plus 6. So 10 take away 6 equals z plus 6 minus 6. 10 take away 6 is 4. 4 equals z. So my answer is 4. So I can check that. 10 equals 4 plus 6. So 10 equals 10. Okay, number 2, we've got 8y equals 48. Now 8y, remember, is multiplication. So in order to, the opposite of multiplication is division. So 8y, and I'm going to divide by 8 equals 48 divided by 8. 8 divided by 8 is 1, which leaves me with my y. 48 divided by 8 is 6. And I can check it. 8 times 6 equals 48. 6 times 8 is 48, and 48 equals 48. Okay, these checks, some of them you might just be able to do in your head. Okay, q minus 12 equals 1. Okay, so I want my q to be by itself. It's negative 12, so I have to do the opposite of minus 12, which is plus 12, equals 1 plus 12. Whatever I do on one side, I have to do on the other side. So now I'm left with my q by itself, and 1 plus 12 is 13. Okay, number 4, we've got 18 equals a over 2. A over 2 is divide. So I get to do the opposite, which is multiply. So I'm going to multiply by what I want to get rid of, which is the 2. So 18 times 2 equals a over 2 times 2. 18 times 2 is 36 equals a, because 2 divided by 2 is 1. Okay, so 36 equals a. So that's my answer. Okay, so just remember to do the opposite. Okay, solve an equation with constants on both sides. So choose one side of the equation to be the variable side and the other side of the equation to be the constant side. So remember, a constant is just a number by itself, no letters attached. 6, negative 14 are constants. Then, so you got to decide. So my x, my variable, is on this side, so the left-hand side of the equal sign will be my variable side. I'm going to get rid of the constant on this side, so that this side, the right-hand side, will be my constant side. So I use the same properties that I just used: addition, subtraction, multiplication, and division, that idea. So the first thing I want to do is get my variable by itself. So I'm going to get rid of that plus 6. So to get rid of the plus 6, I subtract 6, which means that I have to subtract 6 on the other side as well. So now I'm left with 4x equals negative 14 plus negative 6 is negative 20. Okay, now I'm down to just one side variable, one side a constant. So now I need to get rid of that 4. So I'm doing extra steps here. So that's multiplication. So I'm going to divide both sides by 4. 4 divided by 4 is 1. That leaves me with my x. Negative 20 divided by 4 is negative 5. So x equals negative 5. And again, I can check that. 4 times negative 5 plus 6 equals negative 14. I put in the negative 5. 4 times negative 5 is negative 20. Plus 6 equals negative 14. Negative 20 plus 6 is negative 14. So negative 14, of course, equals excuse me, negative 14. Okay, 2y minus 7 equals 15. So here again, I need to decide which one's going to be constant, which one's variable. This is the same as last time. I've got my variable on the left, so I'm going to keep it there. I want to get rid of that constant so that I have constants only on the other side. In order to get rid of the minus 7, I have to add 7. So that means I'm adding 7 to both sides. So that leaves me with 2y equals 15 plus 7 is 22. Now I need to get rid of that 2, so I'm going to divide both sides by 2. That leaves me with y equals 11. Okay, so my answer is 11, and I can check that. So we're pretty much out of time. So for today, you're going to work on key question 19. Solve the following equations. Be sure to show your steps. Take your time with these. Okay, so remember opposites, addition, subtraction. There's this E and F have constants on both sides of the equal sign. So those are the only two that you might find a little bit tricky. Okay, work on those, and then next week on Tuesday we will continue on with solving equations, and we'll get a little bit trickier with them, add a few more steps in there. All right, so that's it for our class today. Try to get those two key questions finished and send them out to me as soon as you can. Call me if you have any, contact me if you have any questions. Other than that, enjoy the rest of your day and have a great week. Miigwech.